All right, so I'm going to be trying to set a record on this. Try to get as many done in 20 minutes as possible. For every week, Nora buys oranges. They used to be 49 cents. Now they're 69 cents, which means there's a difference here of a grand total of 20 cents. We're buying 6 of these oranges. 6 times 20 cents is, and since it is dollars and cents, you have to put the 0 in there. If it isn't dollars and cents, you can get away with not having the 20, but since it's 20 cents, you can't have 0.2. Sorry. All right, so Chris has a line. Now we have slope-intercept form, so we know that the y-intercept is going to be 0, 7. And we want to find the y-intercept and the x-intercepts of both Chris's and then Sebastian's line. I'll get to Sebastian in a second. So here we go. So for the x-intercept, y is equal to 0, so we get 0 is equal to 3x plus 7. So that means negative 7 divided by 3, because move that over here, then divided by 3, is equal to x. So we get negative 7 thirds 0. And now for Sebastian, we know that his intercepts are exactly twice that. So that's going to be 0, 14, and negative 14 over 3, 0. All right, so right away we know his equation is y equals something x plus 14. Now for his x-intercept, so same process, we know that 0 is equal to his a value times 14 over 3 plus 14, right? So, okay, train tracks, subtract 14, and we get negative 14 is equal to a times negative 14 thirds. So I'm going to multiply by negative 3 over 14, which means the 14s are going to cancel out, and I'll just get 3 is equal to a. So 3 plus 14 is 21. Sorry for going fast on that, but I need to get home before I get in trouble. All right, so an amateur basketball league, a game consists of 20-minute halves. So after 12 minutes, we know that the B's and the C's, we know the C's are up 21 to 18. Well, I know that 20 over 40 is equal, sorry. I know that, so what I did here was I said 40 minutes divided by 12, that's not equal to that, is equal to 3.3 repeating. Well, so all I have to do is multiply 3.3 repeating to each score, and I'll get the team scores, right? So, come on. So 3.3 repeating times 18, that's going to be 60. And then 3.3 repeating times 21, that's going to be 70. That is a difference of 60 or 10 points. 10 points. All right. All right, so I'm not going to lie, I struggled on this one. And my mistake was to assume, well, I drew this line first. I assumed that these two angles were congruent. That is not true, and that led me astray. So I know that this angle here is 84. I know this angle here is 32, which means this angle is also 32 because it's symmetrical. Well, I know a quadrilateral has a total of 360 degrees. If I subtract these, I will get this angle here. So when I do that, I will get 212. All right, so now I'm going to shift my focus to this quadrilateral right here. So I know this is 16, I know this is 16, I know this is 212. So that is 212 plus 32, so that gives me 244. So 360 minus 244, so that's 116. So I know that this is 116. Well, that means that these lines, these angles here, form a linear pair. They add up to 180 degrees. So all I have to do is take that value and add it or subtract it from 180, and I get 64 degrees. All right. Feel like we're really moving well here, and then we're going to get to number 8, and we'll do a separate video for that one. All right, so for number 5, so here's the thing. I know that this is that point here, so if I swing this way, I will get a quarter. I don't know what else to say. Other than I know that, so this is 1 and this is 3, so that means this is, so the whole thing together I think is 1/4, but that may be shoddy math. I would just swing it around and visually, yeah, that works out, 1/4. All right. So then moving on, that one's right for the pencil lead method too. Now this one's a tricky problem. Now the first thing I notice is, well, I have a tens digit times 10 because it makes it a tens digit plus a units digit, and I'm squaring this, and then I have the tens digit that is now done wrong plus u, and now and the last thing in the world I want to do is multiply that out. That's just ridiculous. So what I did is, so I know it's a 2-digit number, so I said 10 squared is 100, and I'm not going to put the squareds here. 20 is 400, 30 is 900, 40 is 1600, 50 is 2500, 60 is 3600, 70 is 4900, 80 is 6400, that's an 80, and then 90 is 8100. So I want to look for a difference that is roughly 2000 difference. And so I'm looking here, so I know that the larger number, the wrong number, at a minimum has to be around here. So I look 2000 back and I get somewhere in the 20s. So those are a possibility because I'm going to be doing some guessing and checking in a bit. So then for 3600, 3000 minus 2000, that could be in the 40s. That's less appealing because each number has since you're squaring larger numbers, there's a bigger difference between each square number, so I don't like that as much. And then magenta, 49 minus 2, so that's getting, and for the same reason I like this even less than the green, and then it's going to get progressively smaller. So what I'm going to do is I'm going to I'm going to pick something in the middle. I'm going to go with 25 squared, which I know is 625. That means the other number would be 55 squared. And when I multiply 55 times 55, I could just use the button. I get 3025 minus 625. I know, minus the 300 I missed in the first place. So that's 2400. Now 2400 is really, really close to this. So I'm going to go down by 1. I'm going to go 54 and 24. Let's see what we get. So 24 squared is 576. 54 squared is 2916. I'm going to subtract out the 576, and I get that. So I know these are the two numbers. So then what form do I want? It says, what is the sum of the two numbers, the two numbers she wanted and what she had? All right, so just add that 54 plus 24, and I get 78. I got lucky here, I know, because it could have been some of these other things. But knowing this range this has a bigger gap, there are going to be more possibilities in here than in the other ones. So that's why I started there. And I just started in the middle. All right, here we go for number 7. All right, the counting path problems, not too bad. So if I start here, I have one way to get here. And one way to get here, and one, and one, and one. Right? Same logic here. I have 1, 1, 1, 1, and 1. So to get here, I have 1, 2, or I could just count the 1 and the 1, 2, which gives me 3, 4, 5, and 6. Well, 1 plus 2 is 3, 4, 5, my God, I'm trying really hard to go fast and make mistakes. 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 6 is 21. So right here I have 3 plus 1, which is 4. Well, just following that logic, I have 5 ways to get to this spot here, alright? So then 5 plus 1 is 6. All of these are going to be 5, right? I need this one to continue. So I have 15 here as well. 15 plus 21 is 36. I hope. I should probably look at my notes while I'm doing this. Alright. Yes, I actually do it on paper first, and then, okay, yeah, I'm good. Alright, so then that means this one is 15 plus 5, which is 20. 20 plus 36 is 56. So over here, 6 plus 5 is 11. 11 plus 5 is 16. 16 plus, I think that's a 10, is 20. Oh my God, that's 20. My God, it's 36. That's why I'm looking at my notes. And then 36 plus 52 is 92, so there are 92 ways of getting there. All right, so now I'm gonna go and do a new video for this beast of a problem.